Hi, I'm Vries. I'm a cloud solution architect working for a small consulting company called For.net based in the Netherlands. Today I'm going to show you how you can create your own custom bindings within the Azure Function ecosystem. This isn't hard, you just have to know how to do this. But before I dive into the creation of new custom bindings, let's first do a small recap on what this serverless stuff actually is. Because what does this mean? Does this mean there aren't servers anymore? Does it mean your code just runs magically? Well, not exactly, because there are still servers, of course. It looks a bit like a PaaS solution going serverless, just with a couple of nuances. As Adrian Cockcroft once mentioned in a small tweet, it's a small elevator pitch. If your PaaS solution can spin up really fast, do some compute work and spin down or get destroyed afterwards, you can call your PaaS solution serverless, to say. Of course, there are some nuances to this statement, but it's a nice elevator pitch to get the conversation going. Because the serverless compute, and Azure Functions in specific, is meant to do small workloads and get destroyed afterwards without you caring. The serverless world is still a bit young, a bit fresh. It's the new kid on the block, but still there are some great minds which have thought a lot about how to develop for serverless. One of these great minds is Paul Johnston. Paul Johnston has been working in the serverless space for a couple of years now. He's one of the pioneers. And he has come up with, let's say, 8 best practices which you should or could follow when going serverless. It's a great blog post he has. I recommend reading it and follow him on Twitter if you have any questions. He's quite active over there, but definitely read his blog posts. It's quite useful. But what it all comes down to in the end is you have to think like a cloud environment and not legacy environments which we have been developing for decades on the on-premises environments, because the cloud enables you to think a bit differently about your solution. You don't have to store all of the data inside one big database. You don't have to store files into one single folder. You can just create infinite amounts of storage containers, of queues, of databases, of whatever you want. Just create a single service for a specific case and use it only for this single case, for this single service. That's easy in the cloud, not very much in an on-premises environment. And that's what the serverless movement is all about. Use the cloud environment. Don't think in on-premises environments anymore. A couple of best practices I want to highlight today is these 3. These 3 are mentioned in Paul Johnston, his blog post, and what it means is one function should only do one thing. If you go to the extreme on this statement, you could say one function should never have an if statement, or at least that's how I interpret this practice. And that's true to some degree, because if statements, I like them, but it's actually 2 code paths you have to, maintain and think about. Whereas you could also have a different filter on, let's say a queue message, a topic, a subscription, and get the message you need for one specific function directly, instead of doing some logic on this message inside your function. I think this is a bit extreme, but it's something to think about. One function should only do one thing. Also, don't use external libraries. This is pretty useful advice because all serverless compute implementations like AWS, Lambda, like Azure Functions, like Google Cloud Functions, they have problem with cold starts. Cold starts is what happens when a new instance is spun up with your compute in it and all of your libraries and dependencies. It has to be jittered, it has to be put inside memory, it has to be sent to the actual machine where it's going to run on. So that's a lot of stuff which needs to happen, and you can imagine if your overall footprint of your serverless solution is rather big, it will all have to be shipped and put inside in memory of this new virtual machine, of this new compute unit, which can add up. So don't use stuff like let's say entity framework, which is like 6 megabytes in assembly size, but I also don't use automapper and autofac and stuff like this anymore, because those libraries are quite big. I totally love those libraries. I recommend using them in normal scenarios, but when going serverless I try to avoid them because both of these are about 250 kilobytes, which adds up, and I can do my own dependency injection and my own mapping of objects, because most of the time in my Azure Function solutions scenarios are quite easy to understand, so I don't need these full-blown libraries to help me with my business logic. And the last best practice, the last practice which is used today in my session is know how it will scale. This is a bit of a different practice, because when going serverless you'd say you don't need to know how your serverless environment will scale, but it is still useful, because once you know how your solution scales, you can also leverage this knowledge in your solution. Because what a lot of people think, whenever an Azure function picks up some compute work, because it's triggered somehow, a new instance is spun up. But this isn't true. An instance is reused across multiple triggers, across multiple requests. This is to avoid the cold start every time a function is triggered. Quite useful. But once you know this, you can also use this knowledge in order to keep stuff in memory, to keep state in memory. And you have to be wary about doing this. But let's say an dependency injection container. It takes a couple of milliseconds to spin this up, and you're paying for every millisecond of compute. So it might be useful to reuse this container across multiple requests. Same goes for your database context. Same goes for your HTTP client, which should only live once in your solution, in your runtime solution. So this is stuff you want to know, because now you can leverage this power. So how will you leverage all of this functionality, all of these best practices? Well, as I mentioned in the opening slide, we can do this by adding custom bindings and custom triggers. At the moment, custom triggers aren't supported yet. I think that's on its way, but you can add custom bindings, because Azure Functions goes hand in hand with a lot of bindings and a lot of triggers. Whenever something happens in the cloud, you can, well, do stuff with it. Be it an HTTP request, be it a message on a storage queue, be it a message on a service bus queue, an event grid message, whatever. A blob being added to some storage account. You can do everything with triggers. And with bindings, you can also do some, well, mundane tasks like storing data in a storage container, updating records in a Cosmos DB, creating new records in a Cosmos DB, creating new messages on some kind of a queue. A lot of stuff, a lot of bindings out of the box for Azure services. But sometimes that's not enough. You might also want to, well, create a message inside some Slack channel whenever something is happening inside your Azure environment, or Teams maybe. So for this you need to create your own custom bindings. And creating custom bindings isn't very hard. You just have to know a couple of things and know how Azure Functions, or at least the Azure Functions runtime, is working underneath the covers. So, and what I want to use custom bindings for is for all of my clients I'm using across my application, because clients are hard in my opinion. Take for example the HTTP client. You have to, well, create a single HTTP client for your entire application and reuse this instance. It's something which is forgotten quite often by, well, starting developers to say, but also experienced developers sometimes make the mistake of creating hundreds and hundreds of HTTP clients, which is troublesome if you're in a sandboxed environment like an Azure App Service, because you can only have a couple of thousand open socket connections, and when you spin up a lot of HTTP clients doing calls to wherever, you quickly reach the limits of your app service. So that's why I'd like to abstract away all of these clients, like the HTTP client, but also a SqlConnection, a Cosmos DB, well, whatever other client there is, a file writer, file reader perhaps. So first thing I did when going to create custom bindings, I created a very easy to understand and nice hello world binding in order to help me figure out how to create custom bindings. I'll show you what I did and discuss what you should do according to the documentation and what additional steps you need to do. So what I've done over here is create a small simple binding called my simple binding, and what it actually does is read the contents of a specific file from my local file system and place the contents in a DTO called my simple model. So you might recognize this notation from Azure Web Jobs, which has a similar notation of retrieving well, app settings and variables, and the same goes for Azure Functions. So over here I specify the file path, which is stored inside the app settings, and the name of the file which I want to retrieve, and this name is specified in the incoming request, this incoming HTTP request. You can also use this for DTOs, so if you have a incoming DTO and there's a parameter called name, you can just use the name over here and the Azure Function runtime will make sure it gets resolved from the DTO. So how does this my simple model look like? Well, it only has a full file path and the contents of the file. And the binding is also, well, rather easy to read. It only has a location with an auto-resolve attribute which says retrieve the contents of this parameter or this property from either the app settings or the incoming variables, the incoming parameters, or both in this case. So this is the mySimple attribute. Of course, you have to specify the attribute usage, and it's a binding. So this is my first mySimple binding. The actual magic is happening inside the iExtension config provider implementation, which is called mySimple binding. And there's an initialize method inside this this implementation, which is adding a new binding rule to the mySimple binding attribute, the attribute we just saw. And seeing this is an input binding, so we're retrieving data from somewhere, we have to create the rule with a bind to input and a method which will retrieve the actual data. So the implementation is rather easy, stuff you've probably seen a dozen of times in your career. I'm checking if the file exists on the location specified inside the attribute. So if it exists, I'll read all the text from the file, and the content is placed inside the content property of the model. So rather easy to follow, or at least for me this was rather easy to create. And when running this extension, when running this custom binding, it didn't work. Why didn't this work? Because I actually followed all of the documentation steps. Well, as it happens, a couple of steps were missing, or at least one important step, which is the startup. At this moment, you still have to specify an implementation of the iWebJob startup inside your NetStandard library, which is telling the runtime to add mySimple binding. So what I did over here is create an extension method where I'm adding the extension mySimple binding to the builder, the iWebJobs builder. Of course, you don't need an extension method for this, but this is, well, a small convention I see everywhere, so I'm just conforming to it. One other thing you have to remember is to add this assembly attribute to your solution. I've added this to the iWebJob startup, so it's easy to find, and I hope this plumbing, this iWebJob startup and this assembly attribute can be removed in future iterations of the Azure Function runtime, but at this moment you need this. So when running this code, you'll see my HTTP triggered endpoint will be added to the Azure Function app. It's called Custom Binding Function. It's located in this endpoint, and when running this with Postman, when requesting this endpoint with Postman, I'll receive the contents of a file called test on my local file system. Of course, I have to unpause it, and over here it says hello MVPDays. Just to be sure it's correct, over here is the file called test, temp test. Hello MVPDays, I'm here. Proof it's not fake. As you can see, the response is shown over here. So my custom bindings of reading a file actually works, which is awesome. So that's it for a fairly simple file reader binding. This isn't something you want in your production code, but you do want to use this stuff for expensive things like clients, or at least that's what you want to use this for, in my opinion. So what I did, now that I know how to create a custom binding, I created a couple of other bindings which help me do HTTP calls, but also do some queries on SQL Server and doing some stuff to Event Grid. I'll show you what I created with my HTTP client. It's able to retrieve data from some kind of HTTP endpoint, so it's an input binding, but it's also able to do an output binding, so it's doing a post or a put to some kind of HTTP endpoint. So first, let's check the input binding of the HTTP binding. I've created a new HTTP binding which has an HTTP model, and as you can see there's one property which I have to specify for this attribute, which is the base address of the HTTP endpoint I want to query, the API, and some kind of identifier. And this identifier is located inside the incoming net standard model, which I have specified over here. So when and this HTTP model is also rather easy. It has a response and a response code. So what I'm doing inside this binding is I have an HTTP client which I can specify, but I don't have to, and the URL I need to go to. So opening up the solution, over here is the binding, and as you can see there's a bit more code to it. Of course I still have the new binding rule I have to use with the HTTP attribute, and I've created the bind to input just like we saw at the file reader binding. And the build from attribute looks like this. I have an internal static variable, internal static field which holds the HTTP client, and this HTTP client is shared across instances. So if this one already exists, I will use it, and otherwise I'll create a new one. And I'll do just get async for a specific URL, specifying cancellation token, and the response is put inside my own HTTP model. Pretty much the same as we saw with the file reader. What I also did is create an output binding, an HTTP output binding. Seeing this is a different binding, I had to create a new or a different name for it. So I've created the HTTP command binding, which still has the same command URL. It's a different command URL, but you have to specify where you want to post your command to, which media type you want, and just for the sake of it, I'm also specifying which HTTP method to use. Over here I'm using an iasync collector, which is a collector which is somewhat of a collection where you can add new, in this case, HTTP commands to. You can add multiple HTTP commands to it. At the moment I'm only adding one, but you can add multiple, and once your function is finished executing, it will get flushed and being posted to the specified endpoint. So what I'm doing over here is I'm adding a new HTTP command with some content in it, and I'll be posting this stuff to the endpoint specified. As you already saw, I have an additional binding rule for this, for the HTTP command attribute, and I'm binding it to a collector, so the iasync collector for a specific HTTP command. Because I need to do a bit more stuff over here, I've decided to create a new class for this called the HTTP command async collector, which also needs the attribute. And over here what I'm doing is I've implemented the iasync collector with the HTTP command, so the runtime knows this one has to be used for the iasync collector. And in the add async, I'm keeping track of a local, collection of internal HTTP commands and specifying the HTTP client again if it doesn't exist yet. Once this adding is done inside my code, so once I've added all of my HTTP commands to the internal collection, I'll send a post or a put, depending on which HTTP method I've chosen, to the endpoint using the shared HTTP client. And that's all there is to it, to create an input or an output binding and sharing an HTTP client. Cool stuff, right? Well, now that we know how to create custom bindings, you can use these bindings inside your Azure Function solution, and once you have these in place, your Azure Function can focus on implementing business logic, which means you can focus on adding business logic instead of all of this plumbing code and keeping stuff in memory and sharing it across instances and doing stuff, plumbing. So focus on adding business value instead of mundane tasks. That's the message I want to give to you. So that's it for today. If you want to reach out to me, you can reach me at GitHub, Twitter, via email, or even via my blog. Thanks for watching, and I hope to see you sometime in real life. Thank you.